Okay, guys, I am going to try to record my lectures. I won't be able to have all of this on one video, so I'll probably break it up into different videos. Sorry, you guys are probably going to end up seeing like my emails and things like that. So, hopefully that if you've missed class, I know that some of you are in athletics, so hopefully this will help if you end up having to miss class for a certain reason that you're not completely behind. Okay, so science is a way of thinking about and understanding your environment. And science is really cool. Everything that we experience is science. And I don't know that we think about it really like that. As far as physical science is concerned, it's not always the favored science because it tends to be about things that we don't really see as much. Like, for instance, gravity, or we see things moving because in physical science we talk about motion, but we don't really think about why. And so we talk about things like that. So hopefully you will really find physical science to be pretty interesting. So we are going to try to think about, does this make sense? We're going to try to think about how things in our surroundings have order and maybe some tools and rules that we can come up with. All right, so our overview. We will go through all of this stuff throughout the slides, so I'm not going to read this one for you guys. Our objects and properties. Okay, so you will need to be familiar with terms that you see in this PowerPoint. These will be on possibly quizzes, they will be on tests, and I realize that this has an audio symbol in the middle of the picture here, but it doesn't work. I tried it and I had technical issues, so that's why I'm doing this way. So objects are things that we can see and touch, and then properties are just things that we can use to describe those objects. So for instance, if we said that something was blue, or if it was pointy, or we're giving it some kind of property. I like to play this game called Catchphrase, and what it'll do is it'll give a word, or it will give a phrase, and we have to get our group to try to guess what the word or phrase is without actually saying the word itself. So, for instance, if the word was sky, we might say it's blue, it has clouds in it, there are birds that fly around in it, and somebody might say, okay, that's the sky. So those are different properties. Reference are things that we can refer to, but they aren't the actual object themselves. So we could say this object is kind of sky blue. Well, you immediately think of the blue sky, and so that helps you to identify what that means. And then problems are language that can be subjective and ambiguous and ultimately circular. When we deal with science, we are going to deal with lots of problems. And the thing is that we're going to try to find the solution to those problems either through observation, or we're going to try to calculate something in order to find what it means. All right, so quantifying properties. The thing that I really want you to take from this particular slide is the word units. And units are what give science meaning. So for instance, if I said that something was, I'm going to write on this slide here for a minute. If I said that something was 2 feet, this number right there, if I didn't have the feet on there, that's just math. Okay, math just deals with numbers. But when I put this foot in here, that is science. That is telling me that this that I'm talking about is distance. How do I know that that's distance? Because feet is a unit for distance. And so your units are really important in science. So you need to be able to understand what units mean. Okay? And so this says that there are 3 steps that we want to use. One being that we're going to compare the referent unit to the property being described. 2, we're going to follow a procedure specifying how the comparison is done. And 3, we're going to count how many standard units describe the property under the consideration. So if we're talking about distance and we end up with a unit like feet, then that's pretty good. If we're talking about distance and we're using a number that has a unit of, say, kilograms, then we're not doing exactly what we're supposed to. We need to be finding a different number with a different unit. All right, so that gets us into measurement systems. And so the first type of measurement system is the English system. Many units are based upon parts of the human body. So you can see on this guy here that there are different lengths that it's showing you. But as you know, not everybody is going to be the same size. So the English system is really a terrible use of measurements because it is very approximate. So that is why in science we end up having to use the metric system. And we are going to get into that on this next slide. So the metric system tells you that there are 7 base units. We will use most of these. We will use meters, kilograms, seconds. We do not get into amperes because we don't get into electricity in this particular class. We do talk about heat, so we'll get into Kelvin, briefly talk about moles, and unfortunately we don't talk about candelas because we don't get into light in this class either. All other units are derived from these. So as far as the metric system is concerned, it is pretty neat in the fact that it's based on multiples of 10. And you are going to be required to know how to draw the metric scale. You will be required to know how to do those prefixes, and you will be required to know the numerical values of each of those. I have put a separate video of the metric scale on D2L, so I encourage you after this slide to go to that video and copy down everything that I write as if you were taking notes in class. Okay, so this particular slide is just showing us that there are 4 fundamental properties that you need to be familiar with as far as the metric scale is concerned. We will talk about length, and all it's telling you in that bullet point is that length was determined from the distance that light traveled in that amount of time. Mass was determined by this very specific metal cylinder that they have in some museum or location in Europe. And so we base all of our, kilograms on that particular mass. Time is referred to the oscillation, so that's just a back and forth motion of the cesium atom moving back and forth. And it does this so many times, and I can't remember exactly how many times it is, but that's 1 second. And then the 4th fundamental property is charge. Again, we do not go over electricity in this class, so you won't really see that, but you do need to know that that's one of the 4 fundamental properties. Okay, this next slide is just showing you the those 7 base units again, and the only one that I really want to point out here that's kind of funny is the kilogram. And the only reason I say it's funny is because if you look at all of the rest of those units, they don't have prefixes like kilo or hecto or deca. So why is this considered a base unit? I don't know that I would necessarily consider or say base unit, even though it says that on the table. I refer to this more of like a standard unit. Grams are so small. There are 454 grams in 1 pound. So you start talking about something that weighs quite a few pounds, that's going to get to a pretty big number. So it's just easier for them to measure in kilograms. So that is why that is the way it is. Okay, metric prefixes. All right, so like I said a couple of slides ago, I do have a separate video for the metric prefixes and numerical values. I encourage you to go and watch that video. I'm going to go ahead and stop this video here and pick up on another video.